Okay, this is the final video for calculus and vectors. Woohoo! So, exponential growth. One last sort of concept and example. The general equation for exponential growth. And this is probably the formula that's closer to what you would have seen in the biology if you're taking the 4U biology. So just a couple of pieces of information that would be handy to know. So f of x is your final amount. So final amount. Why not is your initial amount. And why not would you not use why not? A little punchy here. Initial amount. E again is just the the natural growth base. Your K value is your growth constant. It is your growth constant. Growth constant. And finally, T is your time. And as long as you are uniform in what time you use, then it doesn't matter whether you're seconds, hours. Like I said, as long as you're using consistent time throughout. Finally, that growth constant. If the growth constant has a value greater than 1, you then have growth. If it is less than 1, then you'd have what we call decay. All right, so there is your parameters for growth and decay. Okay, so switching over to the final example. Population of Mitchell grows at a rate of 5% per year. So determine how long it will take to double its size. So first of all, we need to find, and I'll put this in steps. Step 1, we need to find the growth constant for the situation. Because what we want to do is we want to, if we can identify, and if you do get a chance to read, I don't know why you would be reading these reports, but when you're talking about population analysis, there'll be a growth factor that's applied to the town of Mitchell, and this is what it is. It's that the K value that fits this particular equation. So we always go after 1 year in the analysis. So after 1 year, if the initial value, so if I use the original formula there, why not? E to the KT, and just checking, did I use an X anywhere? I did, of course. You want to change this in the note. This should be a T. Just scribble that out so that it matches, which means that should be F of T. I know, I can hear you grumping. It's not like it was a big error. Come on. So F of T equals why not EKT. So what I would do is, if this year the growth, let's say there was, 100%, and we go with 100%, then next year there would be 5 more percent, so it'd be 105. Okay, you can really pick 1 and 1.05. It doesn't matter. You can, the bottom line here is you can pick any value you want for the initial growth here, because it's just going to end up being, the 5% there. E, we're looking for K, and the other reason we pick 1 year is the T value goes to 1. So dividing both sides by 100, divided by 100, it's always going to be 1.05 equals E to the K. And again, we're looking for K, so we'll take the ln of both sides, and we end up with K. When you take the ln of both sides, I'll just kind of insert this in like this. The ln and the E function are inverse functions that are they undo each other, cancel each other out, so to speak. So there is our growth factor. All right, so there is our growth factor. So the real equation then for the town of Mitchell, F of T equals, why not E, why not, again, E to the exponent T multiplied by ln 1.05. So what happened was a substitution now. Instead of the exponent KT, K is ln 1.05. So there is the ln 1.05. So it is there and ready to go. So there is our function that we're going to be using. So now we can answer the question. We couldn't answer the question until we have that growth factor. You need it first. So if the population of Mitchell grows at 5%, taken care of, determine how long it'll take to double. All right, so we're looking at how long, doubling time. Well, if y naught is the initial, then 2y naught would be doubled, right? We're just going to double. So 2y naught equals y naught. E, we're looking for t ln 1.05. So the y naughts cancel, and we end up with 2 equals e to the exponent t ln 1.05. Now, some of you might have been asking or wondering, you know, if we break this apart, this exponent, this e, can that just go to a value of 1.05 as a coefficient? And the answer is yes, and I'm going to show the extra steps to show so you have the y, that is. Remember, these two terms are being multiplied. So actually, you know what? Forget about it. I'm just going to continue on how you would normally do this, and then rather than trying to insert some different math in here, or not different math, but math that's not really needed. At this point, you take the ln of both sides. So ln of this side, ln of this side. We do that because inverse operation, it'll cancel out that e. So ln 2 equals t ln 1.05. Divide both sides by ln 1.05, and you have your answer. So the amount of time for the town of Mitchell to double is going to be ln of 2 over ln of 1.05 years. So there you go. That is your final answer. So therefore, it will take ln 2 over ln 1.05 years to double. Okay. Now what I need you to be strong, people. I know this is the last video, and I can see tears out there. But it doesn't have to end here, the math. You have next year, university or college. Always encourage you to continue on with your math, and so be strong when you see me next in class. Okay, I know it will be tough. So this is the final homework segment for the textbook, and I can't stress enough that the handout is extremely important to work on as well. So what we're looking at, you're probably finishing this with a couple of weeks, hopefully a couple of weeks if everything's gone well. And that last week is basically straight work periods. We're just working our way through the homework and making sure that you have a complete understanding of the material. So that being said, that's it. Signing off for the Calculus and Vectors course.